Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P2195, indicates an issue with the air-fuel A-fuel sensor, specifically sensor 1, signaling that it is stuck lean. This code suggests that the engine is running with an excessively lean air-fuel mixture, which can lead to engine performance issues and increased emissions. The A-fuel sensor plays a critical role in assessing the optimal air-fuel ratio for combustion, typically located in the exhaust system before the catalytic converter. It monitors the amount of oxygen in the exhaust gases. If this sensor fails or provides incorrect readings, it can cause the engine control unit, ECU, to make inappropriate adjustments to fuel delivery, impacting engine performance. Understanding and addressing this DTC is essential for maintaining vehicle efficiency and compliance with emissions standards. DTC P2195 signifies a malfunction in the AF sensor, specifically sensor 1, which is responsible for measuring oxygen concentration in the exhaust gases. This measurement is crucial for determining the correct air-fuel mixture for optimal combustion. When the sensor reports a lean condition, it indicates that there is too much air relative to fuel in the combustion process. This condition can result in poor engine performance, increased emissions, and potentially lead to engine damage over time if left unaddressed. Sensor 1 is typically located upstream from the catalytic converter and plays a vital role in the engine management system. Monitoring the signal from this sensor helps the engine control module, ECM, make necessary adjustments to fuel injection and air intake. There are several potential causes for DTC P2195. The most common cause is a dirty mass airflow, MAF sensor, or intake air temperature, IAT sensor. These sensors can accumulate debris over time, leading to inaccurate readings that affect the air-fuel mixture. Another possible cause is a faulty AF sensor. If the sensor itself is malfunctioning, it may produce a stuck lean signal, leading to an improper air-fuel ratio. Lastly, loose or poor electrical connections can result in intermittent signals that trigger this DTC. Checking each of these components systematically will help isolate and address the problem effectively. The symptoms associated with DTC P2195 are often noticeable and can impact the overall driving experience. A primary symptom is poor engine performance, which may manifest as hesitation, stalling, or difficulty accelerating. Additionally, drivers may notice increased emissions, which could lead to failed emissions tests. The check engine light, CEL, will typically illuminate, serving as an indication that there is a problem that requires attention. Other potential symptoms might include decreased fuel economy due to incorrect fuel mixture adjustments. Understanding these symptoms can guide diagnostics and help maintain vehicle functionality. The first troubleshooting step involves inspecting the MAF sensor and IAT sensor. Begin by removing the MAF sensor, which is typically located in the air intake path before the throttle body. Check for any dirt or debris present on the sensor element. A dirty sensor can produce erroneous signals that may cause DTC P2195. If dirt is found, clean the sensor thoroughly. If cleaning does not resolve the issue, it may be necessary to replace the MAF sensor or IAT sensor. After performing this check, proceed to the next step in the troubleshooting process. The second step focuses on the installation and connections of the AF sensor. Inspect the AF sensor, labeled as sensor 1, for any signs of looseness or disconnection from the warm-up three-way catalytic converter, WUTWC. A rolled or dislodged connection can compromise the functionality of the sensor, causing it to provide misleading signals regarding the air-fuel mixture. If the sensor is found to be loose or improperly connected, securely reinstall it. ensuring proper torque specifications are met. If the installation is correct, proceed to the next troubleshooting step. In the third step, begin by turning the vehicle ignition to the on position without starting the engine. Use the Honda Diagnostic System, HDS, to clear DTC P2195 from the vehicle's computer. After successfully clearing the code, start the engine and hold the engine speed at 3,000 RPM without any load. This process should be conducted until the radiator fan activates. This procedure helps mimic operating conditions during which the sensor's functionality can be adequately assessed. After completion, check with the HDS for any new confirmed or pending DTCs. If P2195 reappears, further diagnosis is necessary. The fourth troubleshooting step involves a thorough inspection of the connections to the AF sensor and the powertrain control module, PCM. Poor connections or loose terminals can lead to DTC P2195, so it is essential to inspect and secure these electrical connections. Additionally, check if the PCM has the latest software version. Updates can resolve bugs that may contribute to the DTC's appearance. If an update is not available, or if issues persist, substituting the PCM with a known good unit may help determine if the PCM is at fault. If the original PCM is found to be the root cause after a successful test with the replacement, then replacement of the original PCM is warranted. Final verification of repairs for DTC P2195 involves running comprehensive vehicle diagnostics after completing the recommended repairs. It is crucial to ensure that all DTCs have been cleared and that the trouble code does not reappear. Conduct a test drive to assess overall vehicle performance and confirm that there are no symptoms related to the initial DTC. During this drive, pay close attention to engine responsiveness, fluctuations in RPM, and any warning lights that may illuminate. If all systems function correctly and no codes reappear, it indicates a successful resolution of the issue. Preventive maintenance is essential to avoid future incidents of DTC P2195. Regular cleaning of the MAF and IAT sensors can prevent dirt accumulation that leads to performance issues. Additionally, it is advisable to conduct periodic diagnostic checks to identify and rectify potential issues before they escalate. Monitoring fuel quality is also vital, as low-quality fuel can impact engine performance and sensor functionality. It is ideal to fuel up at reputable stations to maintain optimal fuel quality. By instituting these practices, vehicle owners can promote long-term performance and reliability. In conclusion, DTC P2195 represents a significant issue concerning the AF sensor's capability to provide accurate readings in a Honda Fit. Understanding the symptoms and following a systematic troubleshooting process is essential for effective repair. The process involves initial diagnostics of the MAF and IAT sensors, verifying the proper installation of the AF sensor, and utilizing the HDS to clear and assess any residual trouble codes. Preventive maintenance, including regular inspections and sensor cleanings, is crucial for avoiding similar problems in the future. With these strategies in place, vehicle owners can enhance their car's reliability and performance while staying compliant with emission standards. Please like and subscribe to the channel. See you next time!